In this video, we are going to talk about rational numbers. So rational numbers are comprised of three types of numbers. We have integers, which we learned in the last two lessons, fractions, and decimals, but only some types of decimals. The types of decimals that it includes are terminating decimals, and that just means decimals that end. So for example, decimals that just don't go on forever. So like 0.25, okay? And also repeating decimals. Now, repeating does mean it goes on forever, but it must have a pattern in order to go on forever and be rational. So for example, like 0.3333 ... It goes on forever. And we would write this as 0.3 repeating. Okay? And we also have like 0.6 repeating, which we're going to talk about in a second. Okay? So rational numbers are integers, fractions, and decimals, terminating and repeating. Now, another definition for rational are numbers that can be written as the quotient of two numbers. And what this means is the quotient of two numbers right here, this is fancy for, it could be written as a fraction. It could be written as the division of two numbers, okay? So any of these numbers, all of these numbers can be written as a fraction. Integers, for example, let's talk about the integer number -7. Integers can be written as a fraction because we can write it as -7/1. Okay? It could be written as, that's the quotient of two numbers. This is like -7 divided by 1. That's the quotient of two numbers. So integers are good. Fractions are good because if it's already like a half, then it's already the quotient of two numbers. If it is a mixed number, like 2.5, we can write that as the quotient of two numbers by making it an improper fraction. So the quotient here would be 5/2. So fractions are all good. And decimals are only good if they're terminating or repeating. Terminating decimals, all terminating decimals can be written as a fraction. And the one that I wrote here, 0.25, we know that as 1/4. It's a quarter. Or like money, 25 cents, 1/4. And repeating can always be turned into a fraction. These ones might have to be memorized, but 0.3 repeating is equal to 1/3. And 0.6 repeating is equal to 2/3. So all terminating decimals are rational and all repeating decimals are rational. And the way we prove it is by writing it as the quotient of two numbers or writing it as a fraction. Okay? So let's just talk about example 3. Example 3 is a mixed number. So the way we write this as the quotient of two numbers for mixed numbers is we make our mixed numbers into improper fractions. So we have 1 times 5, which is 5, plus 2, which is 7. So -7/5. This is now a fraction of just two numbers, and so it is rational. Okay. Let's move on to example number 6. We're going to plot this on a number line. And I'm going to draw my own number lines as I go. What number is -5/3 between? I always like to do find the integers that it's between. Well, I know -5/3 is -1 2/3. Okay? So I know that that is between -1 and -2. Okay? So I'm going to draw a number line. I'm going to make sure -1 and -2 are on my number line. I'm going to put a few other numbers too. I'll put 0, I'll put -1, I'll put -2, and I'll put -3. Okay? I know it's going to be somewhere like in here, but we want to make it a little bit more exact than just kind of estimating. So what I'm going to do is I'm going to add more numbers on my number line. And since my fraction is in thirds, we have 2/3, it's divided into 3 parts, I'm going to make 3 parts in between each whole. So by making 3 parts, I only have to put 2 hash marks because there's 1 space, 2 space, 3 spaces. Okay? So depending on how many parts we need, we only need 1 less hash mark. So I'm going to put each whole into thirds. Okay? And then I'm going to plot -1 and 2/3. Here's -1. Here's -1 and 1/3. So -2 and 2/3 is right here. Okay? And I don't even have to put the numbers under each one of these. I don't have to because they have its meaning already based off of the holes and based off of the hash marks. And let's do one more that's a decimal. Let's do number 9. Vera owes her brother, we'll do number 9. Vera owes her brother $1.70. The debt is represented by -1.7. Plot it on a number line. So -1.7 is between, -1 and -2. So I'm going to plot my number line. And I'm going to kind of do the same thing as before. We'll see. I'm going to just add a couple extra holes on there. So 0, -1, -2, -3, evenly spaced. But this one, we need, actually I'm going to do a little bit less. I'm going to do just 3. I'm going to do 0 to -2. I have 0, -1, and -2. The reason I changed it is because 0.7 is the same as 7/10. So I know I need 7 hash mark. I know I need 10 parts in between each hole. So I'm going to do that. I know I have half is in the middle. So this is -1/2. And half over here is -1.5. And then I need 5 parts on each side. So I'm going to do 1, 2, 3, 4, 1, 2, 3, 4. 0.1, 0.2, 0.3, 0.4, 0.5 is already there, 0.6, 0.7, 0.8, 0.9. And -1.7 this is half, this one is half, this one is 0.6, so right here is 0.7.